Welcome to Trisotech's HL7 AI Challenge 2025 presentation. In this demonstration, we'll show how different types of artificial intelligence can work together with BPM Plus models to enable standardized, explainable clinical decisions. Our focus is on using deterministic models and HL7 standards to give AI agents the structure and context they need to act safely and autonomously within healthcare environments. Let's explore how this approach can support smarter, more trustworthy AI in clinical workflows. Before jumping into the demonstration, we want to share the core AI principles that guide our approach at Trisotech. First, we prioritize decisions as the core of business value. Second, we treat AI as a tool, not the value itself. Third, we promote augmented intelligence rather than trying to replace humans. Fourth, we emphasize explainability. AI must be understandable and traceable, especially when it's used in complex or high-stakes environments like healthcare. Finally, we elevate knowledge over raw data. These principles ensure that AI remains safe, effective, and aligned with real-world needs. Here we have an example that we'll be referring to throughout the rest of the video. It represents an initial anemia assessment process, modeled using the BPMN standard. The process begins by collecting basic patient information. This information is then assessed using World Health Organization guideline to determine if anemia might be present. If there's no sign of anemia, the process ends. But if anemia is suspected, a second round of data collection takes place. These values are used to determine the likely type of anemia through a follow-up decision. What you're seeing here is called a platform-independent model. It's a technology-neutral way of defining clinical logic that can later be implemented using different tools and standards. The anemia severity assessment uses a DMN decision table based on World Health Organization criteria to classify anemia as mild, moderate, or severe using age, sex, and hemoglobin levels. This structured, machine-readable format ensures the logic is clear, consistent, and explainable for both clinicians and AI systems. A more complex decision diagram is required to capture the anemia classification. This model combines multiple decision points. The logic is defined through decision tables and simple calculations, which ensures the classification is consistent, explainable, and easy to validate across different systems. This deterministic model ensures every outcome is predictable and traceable. Inputs and results can be reviewed step by step with a clear visual path that makes the logic transparent and auditable, key for trusted clinical decision support. To create a FHIR-based version of our anemia assessment model, we integrate it by pulling patient data from standard FHIR resources. Using simple mappings, this data is connected to the platform-independent model, allowing the clinical logic to run smoothly within HL7 compliant systems. Now that we have established the clinical context of our demonstration, we will do 4 demos. One using CDS hooks automatically triggered within an EHR, one using a Smart on Fire app initiated by the clinician, one using a conversational AI agent equipped with the anemia model as a tool via the MCP protocol, and finally, one using an AI agent as the actual performer of a task. The first demo scenario uses CDS hooks to embed the anemia model in the EHR. When a clinician views a patient, the assessment runs automatically, showing anemia status and severity in real time, without any manual steps. In the second demo, the clinician used a Smart on Fire app. This attended app let clinicians review and confirm patient data before running the anemia assessment. This ensures accuracy, and all inputs and changes are saved for full traceability. In this third demo scenario, we connect the initial anemia assessment model to an AI agent that can be accessed through a simple chat interface. The clinician interacts with the model by typing natural language questions. The AI agent determines when to invoke the anemia assessment tool and which inputs to provide based on its understanding of the tool's purpose. Here, in the Agent Studio interface, we can track exactly how the agent calls the BPM Plus model, retrieves the results, and formats them as part of the conversation. The agent can also continue the dialogue, answering follow-up questions, such as assessing another patient, by reusing the same tool. While this example uses only one clinical model, the agent can be equipped with multiple tools to support broader diagnostic or risk assessment capabilities, offering a highly flexible, human-centered interaction model. In this final demo scenario, we extend the SMART on Fire-based BPM Plus model by adding a new task, generating an explanation for the patient. Traditionally, this task would be done by the clinician, who would review the anemia type and severity and write a personalized explanation, possibly taking into account the patient's preferred language. Now, we can assign that task to an AI performer, specifically, a large language model capable of generating human-readable explanations in multiple languages. To maintain oversight, this step can also be configured as an attended task, allowing the clinician to review and approve the AI-generated explanation before sharing it with the patient. This balances automation with clinical judgment and personalization. Let's now have a brief look into the technical details behind our 4 demos. The first demo integration uses the HL7 CDS hook standard to connect the BPM Plus model with the Fire-enabled EHR. Trisotech automatically exposes models to the CDS server, which triggers the anemia assessment when a patient is viewed. Results appear as cards in the EHR with no extra steps for the clinician, making the integration seamless and transparent. The second demo integration uses the HL7 Smart on Fire Standard to launch the BPM Plus model as an app within the EHR. Clinicians can start it on demand, review patient data, and interact with the model, ensuring human oversight of the decision-making process. The third demo integration uses the Model Context Protocol (MCP) to connect the BPM Plus model with an AI agent, in this case using Microsoft Azure Copilot. The clinician interacts via text chat while the agent communicates with the BPM Plus model behind the scenes. Patient data is pulled from the Fire server as before, but only the final anemia results are shared with the agent, protecting sensitive clinical data. In our last demo, we assign an AI agent to perform a specific user task in the Trisotech Digital Enterprise Suite. The clinician experience remains the same, while the AI handles tasks like text generation, preserving deterministic clinical logic, and using AI where it adds the most value. This concludes our 4 demos showcasing how Trisotech leverages BPM plus determinism and HL7 integration to empower AI agents in healthcare. Our approach enables AI that is safe, explainable, and scalable, supporting clinical decision-making and automating care pathways. By transforming trusted clinical logic into reusable AI tools, Trisotech helps deliver better decisions and prepares healthcare systems for the future. If these demos seemed effortless, it's because we've made explainable AI feel seamless. Thank you for watching.